All right, this video is about chapter 8.2, rational exponents. Remember the word rational means two numbers that can be written, or a number that can be written as a fraction. So we're going to see what fractional exponents will mean. So I'm trying to see what kind of exponent I could call x here, such that a to the x would be the same as raising a to the third and then taking the fourth root of it. So we're trying to rewrite what would be equivalent. Well, first I'm going to sort of try to solve for the right side or isolate the right side. So I raise everything to the power of 4. That would give me a to the 4x equals, and on this side the fourth root and the power of 4 would cancel. I'd be left with a to the third. Well, a to the 4x is equal to ax times ax times ax times ax, because you could add those exponents, and that's equal to a to the third. So again, well, actually, this is what I had just done. A to the 4x would be equal to the a to the third. The only way that these could be equal, if they have the same base, would be if their exponents were equal to each other. And so therefore, x is equal to 3 over 4. So that's like a little mini proof to show that if you have a raised to the power of 3 and you're taking its fourth root, that is the same thing as a to the power of 3/4. So when you see a fractional exponent, I think of it as having two parts. This 3 in the numerator is like the power you are raising your base to, and the 4 here in the denominator is the type of root that you are taking. Okay, so if you have the nth root of x, you are raising it to the power of 1 over n. So let's see some examples. So if I wanted to rewrite these in fractional exponents or rational exponents, this is saying that I'm taking the square root. That is the same thing as saying I'm going to raise 36 to the 1/2, because again, the denominator of your fractional exponent is the type of root you're taking. So I'm taking the square root. So 36 to the 1/2 is equal to 6. If you are taking a cube root, that is the same thing as raising 64 to the power of 1/3. Again, this is the type of root I'm taking. This is the exponent I'm raising it to, which is just 1. So this is the same thing as the third root of 64, which we know is 4. If I had the fourth root of 16, that's the same thing as 16 to the 1/4. That means tell me what multiplies by itself 4 times to give me 16, and that is equal to 2. Okay, so let's use those now and start practicing simplifying. So if I had 2/16 to the 1/3, that means the same thing as taking the third root of 216, which it turns out is 6. 6 times 6 is 36, times 6 again is 216. All right, 7 to the 1/2, 7 to the 1/2. Well, that's really the same thing as the square root of 7 times the square root of 7. And when you multiply something by itself, the same kind of radical, the same base inside, you could multiply what's inside, and you're just going to get the square root of 49, which is equal to 7. In other words, they will cancel each other out. You could also have used the rules of exponents here. Since the base is the same, I can add their exponents. 1/2 plus 1/2 is 1. So this is just 7 to the 1, which is 7. So we're going to see using the power of exponents that we've learned before can sometimes make these problems even easier. So here I might try to rewrite it so it looks like the problem that I just had. These bases are not the same, but I do know that 125 is 5 to the third. So I can rewrite this base of 125 as 5 to the third. So this is the same thing as 5 to the 1/4 times 5 to the 3/4. And now that they have the same base, I can add their exponents. 1/4 plus 3/4 is 1. So this is 5 to the 1. So these are just a variety of ways that you can manipulate these fractional exponents. 0 raised to any power is 0. Now this one, we have to be careful with the negative. The order of operations would say I would do the exponent first. And this negative on the outside is like it's being multiplied by -1. So if you wanted to rewrite this, you could as -1 times 9 to the 1/2. 9 to the 1/2 means the square root of 9. So this is -1 times the square root of 9, which is 3. So this is -3. Notice this would be different if I gave you this. This says take the square root of -9, which as of right now we'd say does not exist. Okay, so those are two different problem types that we'd have to be thoughtful of here. Here, I'm going to use the properties of exponents that we learned earlier in the year. Inside of this parentheses is multiplication. So I can take the exponent and apply it inside to each of these. This would be 81 to the 1/4. And when I raise a power to a power, I multiply those exponents. So this is x times 8 raised to the 8 times 1/4. This is still 81 to the 1/4. 8 times 1/4 is equal to 2. So this is times x to the power of 2. I'm going to simplify this if I can. 81 to the 4th root means tell me the number that multiplies by itself 4 times to be 81, and that happens to be 3. Okay, so this is just summarizing what we've talked about before. If you see a fractional exponent of m over n, then m is the power you are raising it to, and n is the type of root that you are taking. So if I wanted to write this in radical form, which is what I'm asked to do, again, my numerator of my exponent is the power, the denominator is the root. So this is going to be x raised to the power of 3, and you're taking the 7th root. Notice the order of this doesn't matter. This is the same thing as taking the 7th root of the base of x and then raising it to the 3rd. Those are mathematically the same thing, okay? We don't really have a rule excuse me, sorry, ran out of my problems here.